Hello, and this time we're talking about Pythagoras, not specifically the bloke in ancient Greece who did lots of different kinds of geometry and very, very popular chap, knew lots of stuff, invented lots of stuff. Might not have invented the old Pythagoras' theorem, but we attribute it to him because he did a lot of work on it, so that's okay. We don't mind that. And how does this work? Well, it's all about right angle triangles. Well, you can see I've got 3 right angle triangles here. It doesn't work for non-right angle triangles. You can amend it into the cosine rule, but that's another video. So if you've got a right angle triangle, what you might not know, and if you don't, I'll tell you now, is that the side that's opposite the right angle is the longest side, and we call it the hypotenuse. Okay? But for the way that we write Pythagoras' theorem, we actually label it C, which is a little confusing, but there we are. It doesn't matter which way around you label A and B, because these are the two short sides compared to the hypotenuse, and so whether you put A there and B there, or A there and B there, it makes no difference to me whatsoever. And what Pythagoras says, you might have heard of A squared plus B squared equals C squared, but what it's actually saying is that the short side, the first short side, let's call it short one side squared, plus the second short side squared equals the long side squared. That's what it's actually saying. So it doesn't matter how these get labelled. If someone labels it, just to confuse you, labels it BCA. Don't start thinking that this side squared plus this side squared is this one because of how they've labeled it. No. You've got to look at this and be like, this is the long side squared, so square that and add them together and you get this one. So you just got to think about it carefully. So I always remember this, the short side squared and added is the long side squared. Now Pythagoras wouldn't have done that because they didn't do algebra like we did, so he was like, the size of the square made on that side and the square made on that side is the same as the square made. Yes, he actually did it in squares, but it's the same thing because the area of that square is that side squared. So, it's all right. It works. Now, of course, if you're given the long side, you can rearrange this and say that the long side squared minus the short side squared equals the other short side squared. So it works both ways. Now let's have a look at the 3 examples. Oh, last thing, obviously we don't want the squared answer, so we square root it at the end. And because these are lengths, we can't have the negative answer. If you know that if x squared equals 16, then x could equal plus or minus 4, couldn't it? Okay, because minus 4 squared is 16. But because you can't have a negative length, that doesn't make any sense, we only need the positive values in this. Okay, example time. So we want the hypotenuse. We know it's the hypotenuse because it's not touching the right angle. It's the longest side. So we're going to do 20 squared plus 15 squared, and that will give us this side squared, so we're going to square root it. I'm going to do it all in the calculator just like that. So let's move that across. Big old square root. 20 squared plus 15 squared. Oh, no, that's a 5. 15 squared equals, and the answer is 25. Now, very rarely do you get answers that are whole numbers. They've just, these examples, oh, actually, that one might give me decimals, I don't know. But I think they've chosen these examples just to be neat and give you situations where you do get whole numbers. Usually you get some horrible decimal, and you just round it to 3 sig fig, let's say. Okay, this time they've given us the hypotenuse. Look, it's not touching the right angle. So this is going to be 30 squared minus 24 squared, because, yes, long side, take away the short side, will give us the other short side. Square root the whole thing, and let's do that on the calculatrice as well. Big old square root 30 squared minus 24 squared equals 18. Ah, look, they're giving us nice whole numbers. Centimeters, got to put on the units. And then finally, again, they've told us the hypotenuse, so it's a subtract one. Remember, it doesn't matter which side is which. I have to say, oh, well, it's B and it's A, and who cares? Just the long side squared, take away the short side squared, and we're laughing. So big old square root 8.5 squared minus 7.5, nope, 0.5 squared. There we go. And we get the answer of 4. So it was still a nice whole number. I suspected it might go to decimals, but they've been kind, giving me units, giving me nice whole numbers. But if you do get a strange square root, then don't worry about it. Let's say you've got a square that is 5 by 8, yeah? So you say, okay, well, 5 squared plus 8 squared equals, and then square root the answer equals, unhelpfully, root 89, which you can either just leave as it is. If the answer says, if the question says give your answer in exact form, leave it as a surd, but otherwise press ST, and 9.43 sig fig, unless it says otherwise, is the sort of gold standard, really. And then you obviously write that down. Most answers will come out with a decimal. They've just been kind to me with my examples here. If you have any comments or questions or queries, pop them in the comments down below. Otherwise, cheerio.